This is our second session looking at the fusion behind this box. Last time we took a look at how to model a socket. This time we're going to look at how to model all the recesses that allow the sockets to sit in here properly. Check it out. Welcome back to the second video in the series for building the DPT box. We're going to get started right away creating a sketch, and it's on a new component called box body, and we're creating a rectangle that is 6 inches by 12 inches and then offsetting that 3/8 of an inch, 0.375 to the inside. Sorry about the speed here. We'll slow down in just a second. But you'll see as we go through this, I'm actually designing the box as I go, so everything won't happen beautifully the first time around. There will be some changes and recoveries from mistakes and things like that. So first thing we're going to do, we stop the sketch, and then E for extrude, and we extrude up the outer lip of the box 1/2 inch. And then we turn the sketch back on, because once you extrude it turns the sketches off. And then we hit E for extrude again, and you'll see a mistake there. We'll pick those two pieces of our sketch geometry, E for extrude, and then we're going to come down 1 inch. So there we go, we have an 1 inch deep box with a 1/2 inch rim around the top of it. Sorry for the roller coaster ride. Sometimes Fusion gets a little crazy with the orbit command. The next thing we're going to do is create some recesses for our hinges. So we're creating a sketch. We're using the top of the rim around the box as our sketching plane. So we're creating a few lines here. It's L for line. And you'll notice some of them don't have the little hammer icon for perpendicular. So I'm having to go back in and redraw them. This one over here doesn't have it. So we're going to delete it, create a new line, L for line, and then you'll see the hammer icon is there. We're going to create some dimensions. So it's D for dimension, and then you can just type in 2 inches to keep those lines 2 inches apart. You'll notice this one doesn't have the hammer either. And when we put the dimension on it, something doesn't look right. So we just delete it and then create another one. Make sure it's perpendicular. Hammer's there. We're all good. D for dimension, 2 inches. D for dimension, 2 inches. And all of our hinge sketch is done. So we stop the sketch. Now you can see we have these two faces that have been created that we can extrude. For some reason the extrude didn't work here very well when I selected both of these faces. So here you'll see that I try and say to object, and then I pick an object, and then we get kind of a no dice situation. Don't know why. So then I pull on that and then pick the 2 geometry, and it actually extrudes the 2 geometry as well. So that didn't work, so undo. And we'll try it again individually this time rather than doing both at the same time. So you'll see later in this video that a similar thing happens. Actually, it'll be in the next video, I'm sorry. But later in this series that similar things happen when you try and extrude multiple geometries sometimes. So there's another failure. It just kind of, you sit back and scratch your head and say why, and you just keep trying until you get something that works. So there we go, E for extrude. We're going to try and turn some sketches off to, there we go, get our selection better. And finally that one worked. And of course it turns our sketch off once it does work. And we turn it back on, grab the other face, E for extrude, and then select the geometry that we want to extrude to. So it worked in a roundabout way, took a little more effort than I'd like sometimes, but you know what, that's how things go, and we just roll with it and recover. We now need to create a point to snap to for each of the sockets that we've laid out. So a point at the center of each of the sockets. We're going to create a new sketch and use the face of the box as our plane, our sketching plane. Then we'll go to sketch and then point, and we'll pick the circles, a circle at each of the sockets. So it doesn't matter if you pick the outer diameter, the inner diameter, or what, you just pick a circle and it'll put a point at the center of it. Since we're sketching on a plane, it will align those points to the face of that plane. And then we're going to turn all the sockets off so that we have a nice clear view of what's going on. So you can see a dot for each of the sockets. I turned on the sketch geometry for one of the sockets here. It just happens to be the top left socket, so that I could steal some of the sketch geometry by using sketch, project, include. And you can see the little scallop arcs that I just stole. And then I also need to steal the outer ring around the sockets as well. But I'm going to rotate these scallops first 30 degrees so that they line up kind of north and south in terms of their orientation, so it looks nice in the box. So now we project this last line here, this last circle. Here we go. Sketch, project, include, and project. We grab that circle. And then we're going to offset that circle 1/8 of an inch. So O for offset. And then we grab the circle and type in 0.125 for 1/8 of an inch. And that's because my tool diameter is 1/4 of an inch. And I wanted to make sure I had enough clearance there. So if my diameter is 1/4 of an inch, the radius is 1/8 of an inch. So right now I'm drawing some lines to connect that scallop geometry to the outside of where we're going to cut. So the bigger ring is the outside that's going to be cut. So I'm drawing 4 lines just to connect that arc to the outside. So there's a line there, and that should be it. We can stop our sketch. So now that we've got the geometries created, we can stop the sketch, and then we'll turn off the socket geometry. Sorry for the roller coaster ride there. We'll turn off the socket geometry or sketch geometry, and then we'll select kind of 3 faces. And sometimes it's a little bit of a game to get Fusion to make the selection you want, because there's so much stuff that gets turned on when you're sketching. So you'll see that it wants to create a cut, and I change it to new body. And what that does is, instead of this piece just cutting the box, which would be okay if we only had 1 socket, if I create a new body, now I can copy that new body around as many times as I want, and then we'll come back later and cut the geometry. So right now I'm going to copy this little plug, if you will. And so I'm using the move command, and then you click the create copy and tell it to move. This is just an arbitrary dimension right now. So we'll come in, zoom in a little bit, we'll move this off the mark, so to speak, so that we have some room to work. And then we're going to use a point-to-point move, and we're going to select the center point of our plug and then the center point of our circle. So all those points that we laid out are now coming to be very useful because we're using them to snap our plugs. So now we just got to copy this around about 20 times, and then we'll just speed up through that to copy this around. Now we have all of our plugs. We turn our box back on. We go to Modify, Combine. We select our box as the target, and then the tool bodies, we're going to select all of those plugs. Right now it's set to join, and we're going to change that to cut. So each one of those will cut. You can keep the tools if you want, or right now we really don't need to keep those tools because we're not going to use them in any other operations. Back to our friend, the square adapter socket. It's the oddball in that it has the square piece that actually we invert this socket in the box so that it'll sit right because it has a lip in the wrong place. So I need to create a recess for the square adapter to drop down into. So I'm creating a circle sketch. We're going to turn that back on, and then you'll see I'll whip up into 3D here, and we're going to grab that circle sketch, extrude it down. I can't remember the dimension there. Maybe it was 1/4 of an inch or so, and that provides a recess. The next thing we're going to do is go to Inspect and then Section Analysis. We're going to create a new sectional analysis so that we can see this thing in section. This is really great. It's like taking a loaf of bread and slicing it. You get to see anywhere in the mix. And we're going to move that socket down into place. You actually need to select on the body grid. Yeah, here we go. There it is. Grab the body, move it down, and you'll see that it fits pretty well into that groove. It looks like it's all going to work out, but I should rotate that socket so that it lines up, so that the scallops line up with the little nubs there that are supposed to keep it in the box when it's in place. So we'll just rotate that around 30 degrees and it will line up. So you can see in section the socket there, and then I grabbed the wrong one, the 17 millimeters, the one we're working on. So I'm going to bring it down just below the lip of the toolbox. I'm going to type in a nice round number. That was 0.8, and it's still sticking up just a little bit, so I think I'm going to move it down again, a nice round number like minus 20 thousandths, I think is what I move it here. Yeah, minus 20 thousandths. So it's just below the rim of the box. Now we're going to use Q, which is press pull, and pull that face down so that the socket has enough room. Again, this socket is rotated 30 degrees off, so we're going to rotate it, and that should allow the nubs to line up with the scallops in the socket so everything looks nice and clean. Now we need to make sure those little nubs give enough clearance for the socket to sit down, so we're going to again use the Q press pull, and we're going to pull those down. You'll see the socket kind of go on and off, and it's all to make selections. So use your light bulbs over there to get things out of your way to make selections, and then turn them back on when you need them. So both of my little handler nubs there are in the right spot, and you'll notice the socket still interferes with the box on the top, so I'm going to use a hole. So create hole, and we're going to size that appropriately. It's just going to be just a little bit, a skosh bigger than the socket, and you'll see it's cutting the socket geometry as well. So we're going to go over to Objects to Cut, turn off the 17 millimeter so it only cuts the box, and just pull that into place. Now we should be able to see the socket fits really well. We'll turn it kind of on and off, make sure. Yep. And everything looks cool. Repeat that 20 times for the other sockets, and that's how this whole set gets put into the box. We've got a little bonus round here. After I did my prototypes in foam, I came back and I noticed the space between the sockets wasn't going to work. It's just like paper thin, and you can see it in the model here. Just look between these sockets and it's just paper thin. So I started a new sketch, and I use the Project Include, and I'm selecting the outer geometry of all those sockets. Those are the offenders there. I think there's 10 of them. So what I want to do is put a fillet between each of those and just kind of run one into the next, if that makes sense. So we're going to draw a line here down the middle of all of these so that we have something to use as a trim surface, a trim edge, I guess is what I would call it. Yeah, we're going to select this, right click, and say break link. And once you do a break link on the geometry, you can trim it and you can edit it. Once you do a break link on a projected geometry, you can edit it and do what you want with it. If it's red, it means that it's projected and then it's linked back, and you can't really do much with those. So we're going to use our T for trim, and we're going to trim up all of these little bits in here so that we can put a radius on them later. And you'll see some other geometry poking through. So there was 2 circles for each socket, which gets a little confusing sometimes when you have one piece of geometry over the next. You can't always tell why there's a problem. The next thing is we're going to create some circles, and for some reason Fusion doesn't like to fillet between 2 arcs, which I find pretty strange. So then I'm going to try a 2 tangent circle, and Fusion doesn't like to have tangents between circles, which is totally counterintuitive. So then it's, you know, does a 3-point circle work? What is it? Definitely don't do the 2 tangent again, Greg. It's not going to work for you. So we try it again, and now not going to work. So let's just do a regular circle, and we're going to give it a 1/4 inch radius there, or 1/4 inch diameter, I'm sorry. And then we're going to use our constraints, and we're going to say make it tangent to one circle and then tangent to the other. Whoops. We got to fix all of our geometry that we want fixed. There we go. The green means it's fixed. So now that it's fixed, we can make it tangent. So then we trim everything up. Now we're going to create another circle here. Again, same diameter, so 0.25. And we're going to use our constraints, I believe. Oh, we're going to copy them. I'm sorry. We're going to do all of our copying now. Copy, paste. I think for sketch geometry, you have to do Control V, Control C, Control V, I'm sorry. Control C for copy, Control V for paste, and then it just sort of lands right where the original was, which is fine. And then now we're going to go tangent, tangent, undo, and then we're going to have to fix all of our geometry. Yeah, Greg, if you do it twice, it still doesn't work. Here we go, fix, fix, fix. So fix all of the geometry that you want fixed, make it green. If you select it all, then right click and fix. There we go. Now let's do our tangents. That one to that one, that one to that one, that one, and so on. Now we T for trim, and we trim up all of this. It would have been so much easier to just create fillets, but again, that's not in the Fusion tool set that I know of to do fillets on curved geometry. Again, very strange. I mean, this is something that, you know, old programs like AutoCAD do exceptionally well. And again, I'm coming from the perspective of a designer and not a technician. So a lot of these things I don't know heading into the drawing. I just start drawing and I see things, and when I need to change them, I change them. I don't draw from a piece of grid paper that has all the answers. So again, we convert all of these lines to unlinked geometry, and we're going to draw some circles here. Copy paste a million times. And the fact that Fusion doesn't have like a multi-copy thing is a little bit strange as well. And again, it may exist and I just don't know it. I am not a power user of Fusion. I use it to do what I need it to do. And again, a lot of times it's just sort of brute force. So we're fixing the circular geometry again. Now we're going to start doing our tangencies. So pick all the things you want tangent, and away they go. Doing it this way is going to save us a step. That's right. Sometimes I get smarter as I go. I should just be able to use the trim command now and trim out that center geometry. And you'll notice all of those red lines will come up from the projected geometry because I didn't delete them yet. So I'll probably go back through here if I had to guess. I can't remember, and delete all of that. Yeah, I did. Good boy, Greg. Keep your drawing clean. So now we have a nice piece of geometry there, and we're going to use both of those pieces as extrusions to cut. So tools to cut the geometry that's already there, just to clean it up. And so you'll see as I cut, there's different levels inside of there, because when I was doing this section, taking a look in section at all of this, I adjusted each one to the socket that was there. I didn't make them all the same. And so what I did was pick, I think, the lowest geometry, and I said, okay, let's extrude down to that to make one nice surface there. That makes it easier for the CNC and all the tools. So we're going to extrude this one down. And again, it's E for extrude. And we pull it down, and I should be able to click on one of those faces and say extrude down to there. But as we go, we can extrude small segments, so that could be Q for press pull, and then I select that, everything's on the same plane. You see just to the left there, we got one little straggler right there, and Q for press pull, grab, here we go, Q for press pull, grab, oh, Fusion, come on baby, there we go, grab that guy, there it maybe. Nope. Okay, now grab that one. And again, Q for press pull. Grab that as a 2. It's just not going to happen, is it? Fusion's doing the freak out. There we go. Extruded it a little too far, brought it back up, and it worked. So that is it for this round on the box. The next time that we get together, we'll be taking a look at the actual DPT handle and how I use project include to extrude that geometry. I added some thumb holes, we put a socket wrench down below it, and then we'll also add in the recess for the bracket that holds the DPT wrench to a power drill. So thanks for joining me. I hope everybody learned something, and we'll see you next time. Feel free to click or tap on the images to check out some of my past builds. If you like my videos, click on the Greg's Garage logo and all my future videos will show up in your YouTube feed.